How is an oblique cylinder different from a regular cylinder? Have you ever wondered how different types of cylinders can change our understanding of shapes? Today, we will break down the differences between a regular cylinder and an oblique cylinder. First, let's define what a regular cylinder is. A regular cylinder, also known as a right cylinder, has its sides standing straight up. The sides are perpendicular to the circular bases, which means they from a perfect 90-degree angle. Imagine a soup can. That's a classic example of a regular cylinder. The axis that connects the centers of the two bases is perfectly vertical. Now let's look at the oblique cylinder. This type of cylinder leans at an angle that is not 90 degrees to the bases. The two circular bases remain parallel, but the axis connecting their centers is slanted. Picture the Leaning Tower of Pisa. It's a real-world example of an oblique cylinder. Even though these two shapes look different, they share a common formula for volume. The volume of both types of cylinders is calculated by multiplying the area of the base by the perpendicular height. If you have an oblique cylinder and a regular cylinder with the same base radius and perpendicular height, their volumes will be the same. This is because you can visualize the oblique cylinder as a stack of thin circular discs that have been shifted sideways without changing their volume. However, when it comes to surface area, things get a bit more complicated. For a regular cylinder, calculating the lateral surface area is straightforward. You simply take the circumference of the base and multiply it by the height. But for an oblique cylinder, you need to consider the slant height, which requires some trigonometry to figure out. To summarize, a regular cylinder has sides that are perpendicular to the bases and a vertical axis, making it easier to calculate surface area. An oblique cylinder has sides that lean at an angle, with parallel bases, and while both types have the same volume if the dimensions match, the surface area calculation is more complex for the oblique cylinder. Understanding these differences helps us appreciate the variety of three-dimensional shapes in geometry.